We know that 3 multiplied by 3 multiplied by 3 multiplied by 3 is 81. In fact, we know that 3 to the power of 4 is 81. Now, a logarithm is a number that shows how many times a base number, such as 3, is multiplied by itself to produce a third number, such as 81. So, a logarithm is a number that shows how many times a base number, such as 3, is multiplied by itself to produce a third number, such as 81. So basically what you're saying here is the logarithm of um, the logarithm here basically will be 4. So the logarithm uh, is 4. Well, I know there's some confusion here. Well, just pay attention to the definition of a logarithm. Now remember, it's a number that shows how many times a base number such as 3 is multiplied by itself to produce a third number such as 81. Um, you know, so the logarithm is basically the exponent in simple words. And in fact, this is how we write it in mathematics. We say the logarithm um, of 81 with a base of 3 is 4. So the logarithm, some people can say, some people they say it this way: the logarithm to the base of 3 of 81 is 4. You can also say the logarithm of 81 to the base of 3 is 4. It all means the same thing. So this is how we write it. And there's a connection between logarithm and exponents. Um, for example, we have this relationship here. So basically we have this 3 to the power of 4 is 81. And you can see the connection here. You can see that um, here you have 81. Here you have 4, you know, there. Here you have the threes. So there's a connection between logarithms and exponents. In fact, we can write a summary of things. The logs and exponents, of course, they are related. The logs tell us what the exponent is. So I've already mentioned that, but I'll just write that here. Uh, the logs tell us what the exponent is. That exponent is the index here. So this is, in general, what a logarithm is. It's basically a power, an exponent, and it tells us what the exponent is, of course, what it is. Now, I'm going to look at some questions here that can help you to understand logarithms in details. So the first question here is evaluate log to base 5 or 125. One approach that you can use as a student is equate that to x and then convert from logarithmic notation to exponential notation. This is what I mean. So you can write this as 5 to the power x is equal to 125. And you know that 125 is 5 to the power of 3. So basically what we'll end up with here is x is equals to 3 by equating the exponents. Remember, if the bases are the same, you can just equate the exponents. Next, we'll do the same thing, equate that to x. So we want to find x, and that will be log to base 64, log of 4 to the base of 64. So if we convert from logarithmic notation to exponential notation, we'll have 64 to the power x is equals to 4. So 4 to the power of 3 of x is equals to 4, which means that 4 to the power 3x is equals to 4 to the power 1. Equate the exponents, these guys here. So 3x is equals to 1, so x will be a third. Here is another question. Evaluate log to base 4. So equate that to x again. So 4 to the power x is equals to 4 to the power 1. 4, which is just 4 to the power 1. You know that. So x will just be 1. That's it. Next one, equate that to x as well. So 5 to the power of x is equals to 1, which is 5 to the power 0. So x is equals to 0. Next one, we have these guys here. You can use the same process, equate that to x. So n to the power x is just n, which is n to the power 1. So x is equals to 1. Just equating the exponents. B, same thing. 2 to the power x is equals to 1, which is 2 to the power 0. So x is equals to 0. Next one, of course, you can guess it's just equal to 0 because it's very similar to B. We can work it out if you want to see what's happening. If you let this to be equal to x, let that be equals to x, you'll have b to the power x is equals to 1, which is equals to b to the power 0, and then x is equals to 0. Here's another question. Same thing, equate it to x. So 2 to the power x is equals to 2 to the power 5, which means that x is equals to 5, equating the exponents. Next one. Now we have this question in logarithmic notation. We can convert that to exponential notation. So what we'll end up with here is 2 to the power x, 2 to the power 5 is equals to x. So 32 is equals to x. You can also convert from exponential notation to logarithmic notation. So for example, in A, you can say log to the base of 10 of x is equals to 4. Because 10 is the base, and x is on the other side. Here, log to the base of a of x is equals to b. This conversion is actually in a formula booklet. So if it happens that you have a question that involves conversion in the exam, please refer to your formula booklet. They do show you how to change from logarithmic notation to exponential notation. In number 9, write these equations in exponent form. So the opposite of what we just done in A. 10 to the power x is equals to 1000. And here we'll have a to the power x is equals to b. Number 10, solve these equations. So all these equations are in logarithmic notation. I'll solve them by converting them to exponential notation. So convert to exponential notation. So if we convert this to exponential notation, we should be able to solve them. So for part A, what we'll end up with here is x to the power 2 is equals to 64. So x squared is same as 8 squared. And I'm just working this out by inspection. Something squared is equals to 64. That will be 8 because 8 squared is equals to 64. So x will be equal to 8 just by inspecting what you're given. Next question is x to the power a half is equals to 6. What you can do here is square both sides. So opposite of halving is doubling. So what you'll end up with is this and this guys will cancel. Yeah, a half of 2 is 1. So x is equals to 6 squared, which is 36. Next one here, we have this convert to exponential notation or exponential form. So 2 to the power negative 5 is equals to x. So x will be 1 over 2 to the power 5 if you remember negative indices. So x will be 1 over 32.